Prova. Okay. Good morning, everyone. Thank you to be here. And thank you for the customer online. And thank you to Academia for this amazing and beautiful building. We are excited for this first time for us for this event. Me and Nora, we organized this event to talk about water filtration, ice, coffee, and gelato. It will be very, very interesting. So enjoy the day, and after the light lunch, also enjoy the labs. Thank you very much.
Obviously, you didn't introduce yourself. So he's Simone from Scotsman. Hi, everyone. My name is Nora, and welcome in Academia. We are very excited to have this event here today. The idea was to create an event about coffee, but at the same time to look a little bit out of the box and focus on cold temperature. And as you were saying, ice, water of quality, ice cubes, to be correct. And also gelato, because all these components work well with coffee. And but at the same time, you will have the chance to get to know things from different industries. In the morning, we will have 4 presentations. So we will do like the more theoretical part here. Then we will have a light lunch. And after the lunch, it's going to be about tasting. So we prepared 4 spaces. One is going to be run by Carpigiani, where you can try gelato. Then we will have BWT, or Water and More, sorry, who will explain you how to measure quality of water or what to consider when talking about water. We will have the boy group from Academia, from the Team Coffee, Marco, Simone, and Tommaso, who you already met at the bar, explaining and brewing coffee which was frozen versus not frozen. And then finally, we will have the World Coffee and Good Spirits World Champion 2016, Michalis, who came all over from Greece. So enough talking. I will ask Sergio to open the stage with his presentation. Thank you.
This mic? Okay. So good morning again from my side, everybody. We talked this morning about ice. So what's the part of water? What's the importance of water when making ice? Let's start from a very simple question. Simple question need simple answers. What is ice? Ice is simple and stupid answer. Something with the shape of a cube made by your machines. This is very stupid as an answer. More scientific answer, ice is the solid form of water. You know it very well. Water is one of the few elements on the Earth that can pass through 3 different states of aggregation: low temperature, ice, solid; medium temperature, ambient temperature, water, liquid; high temperature, gas, steam. In reality, there are even other elements on the Earth, the gases especially, that can go to liquid and to icy, but they need unhuman temperature. So temperatures like 200 or 300 degrees below zero. So let's say with normal temperature, it's only the water that can pass through the 3 states: solid, liquid, and gas. So this was the simple answer to the question, what is ice? Let's go to something slightly more complicated. What is water? Water is the sum of molecules of hydrogen and oxygen. So 2 molecules of hydrogen and 1 molecule of oxygen combined, electronically combined and replicated billion, trillion, quadrillion times, they make for water, liters and big quantities of water. What most of the people don't know is that the water that we study in school, that's this one, it's impossible to find on the earth. Because the water that we drink every day, the water that we find every day on our taps, comes from here. The clouds, if we go outside and we see there are some clouds in the sky, the clouds are made of pure water, the H2O formula. When it begins to rain, that pure water passes into a layer of carbonic dioxide, CO2, the CO2 that everybody's talking about these days. And the sum of H2O, the pure water, with CO2 creates raindrops that are slightly acid, because the combination of H2O plus CO2 makes for raindrops that inside have H2CO3, carbonic acid. Now, in our minds, everything that is related to acid, because our parents told us, stay far from the acid, they are dangerous, they will burn your hands. So we combine, since we were kids, the word acid with something dangerous. In this case, this is like a miracle, because the life starts from here. If the water wasn't acid, the water wouldn't begin to eat out the minerals that it comes in contact with. Which minerals? All the minerals. This is the infamous table of the elements of Mendeleev that we are fronted when we are in school, difficult to understand. We don't go through all the elements. It would be crazy to talk about all of them today. What really matters to us is that the elements on the Earth are all characterized by a magnetic charge. Some of them are positive, and it's the ones, all the ones from the center moving to the left, they have a plus magnetic sign, and on the left side, on the right side, sorry, there are the ones characterized by the negative sign. Why I have circled only some of them? Because here we have the alkalines, and there we have some elements that usually combine in, how can I define them? In groups. They combine with each other, they attract each other, creating, for example, here's you see calcium. Here we have the carbon and the oxygen, and one molecule of carbon and 3 molecules of oxygen. They have 2 minus signs, so they are strongly negative, combined with the calcium that has 2 pluses, create the lime rock. Mountains are made of lime rock. When the water, the slightly acid rainwater, passes through the lime rock, dissolves these elements, and they float in the water, separated. Calcium stays here, the carbonate, CO3, stays far away from the calcium. When the temperature goes up, calcium and carbonate, they bind again together and they create lime scale in the machines, creating technical problems. Some other elements, because again, I don't want to talk about all of this, but calcium again, with sulfur that is here and oxygen again, can create this is lime scale. CaSO4 is gypsum. Gypsum is the chalk that we use to write on the blackboard. And even CaCO4 can create problems into the machines. Another one that is very interesting to know the origins of is sodium, natrium in Latin, and chlorine. NaCl is the sea salt. And A with a plus, Cl with a minus, sea salt. This happens usually when the water is arriving to our taps coming from the mountains. This happens when the water is taken from the groundwater close to the seaside. These two create limescale. This creates corrosion, especially in the stainless steel in the welding points. So if it's true that the water in our tap is coming from the mountains or from the groundwater, let's talk now about the quality of the water that is delivered to us through our taps every day. When we wake up in the morning and we wash our face and we brush our teeth, when we go to the bar and we drink some water, or we have a coffee, or we have a drink made by valuable barmen like Michalis. There's an interesting, brand new, fresh new regulation. There used to be one that was called the 98/83 European Community that was ruling the water throughout Europe and making the water safe for drinking. With a clear will to make the water even safer for us, citizens of Europe, they have, let's say, just released in the year 2020 a new regulation that makes the municipalities delivering the water to us even more willing to have strict rules on the water. And basically what's written inside the regulation. That the level of the minerals that we have just seen in the slide before, they are controlled and using some chemistry that can diminish some levels if they are dangerous. And the pollutants, basically, they have to not be in our water. If there are pollutants, the water is non-drinking quality. And even here, they have some filters, the aqueducts, the waterworks, to control that we drink water without any pollutant. The other thing that is very important for our health, the drinking water quality needs to have no bacteria at all. This is quite difficult to control. And how do they control it? Adding to the water disinfectants, namely chlorine and chloramine, that make our drinking water quality sometimes smell like a small swimming pool. So, minerals are controlled, pollutants are not allowed to be in the water, bacteria, they try to save our health adding some chlorine that makes the water for smelling not like we sometimes want to be. So, how does now the quality of this well-ruled, well-controlled water, how does this water can affect the quality of the ice that we are making with your machines? 3 sentences. The quantity of dissolved solids, minerals, can make either clear or unclear, turbid ice. So the lower the level of minerals, the more the ice cube will be clear and transparent. The higher the content of mineral of our drinking water, the ice will be, let's say, white, less transparent, with a white core. The quantity of dissolved solids can make a very solid cube that doesn't dissolve into the drink, or a cube that melts down very quickly. Think about throwing natrium chloride on the roads to avoid icing, or now they use calcium chloride because it's less corrosive on the car frames. And the third one, the disinfectant, chlorine and chloramine, make an ice that, when melting into the drink, releases the chlorine taste. And the barman doesn't want it. It's clear. Even the customer don't want a drink that tastes like a swimming pool. Now we come to the filtration system. How can filtration system help us to make, let's call it, a perfect ice? The softeners, we know them very well. It's those systems that are usually under the shelf of a bar, of a coffee shop, that the barista has to remind sometime to refill with salt cubes. Usually they have this shape, automatic softeners. Okay, suppose that the water has some, we don't define the exact quantity, doesn't matter now, some CaCO3, lime scale potential dissolved. What happens when the water goes into the softener? It loses completely the calcium ion, and in place of the calcium, the softener releases the same quantity of sodium. The result is that if we had, before the softener, let's say, a water with 300 parts per million, 300 milligram of calcium carbonate, we will have now a water with 300 milligram of sodium bicarbonate. So we make everything after the softener, coffee, ice, with a water full of sodium bicarbonate, baking soda. The quantity of salts, the quantity of dissolved solids is unchanged. We have changed the quality of the solids dissolved into the water. So, pros and contras. No scale build-up, for sure. The softener works, and works very well, in fighting the formation of lime scale, but somebody has to remind to put the salt cubes inside, and this very often doesn't happen. The mineral levels increase. Why increase? Because in the place of each calcium ion that is kept by the softener releases 2 ions of sodium. So the conductivity goes up. There's even more solids. And the softeners, they don't have any control of disinfectant, like chlorine and chloramine. We need to add an activated carbon cartridge to control, to block completely the bad taste of the disinfectant. The cartridges, in this case our cartridges, but the cartridges, decarbonization cartridges, they are based on hydrogen exchange. The softener uses sodium, the decarbonization cartridges use hydrogen. What happens in this case is that the calcium is kept into the cartridge and the cartridges release hydrogen. The result is a water that is very similar to the rainwater. Carbonic acid dissolved. The water is very poor, is creating a very high quality ice. No scale build-up, because the calcium carbonate doesn't exist anymore, like the softener, honestly speaking. The mineral levels decrease, so now we go toward a very transparent ice. The ice is even very solid, tends to dissolve very slowly. It's easy to install. Just connect 2 hoses, water in, water out, no electricity. The space under the shelf is limited, so there is even more room to put under the shelf something else. And the content of the drinking water of chlorine added by the aqueducts, it's controlled or it's stopped completely by the activated carbon that you find always into the cartridges. The only contra that I find is that the limited capacity of the cartridges. The biggest one, take this for example, the 2XL produces 10,000 liters of water. The most used cartridge in all around Europe is the XL size, the S1, and it produces like 6,500 liters. So compared to the softener that you just need to put salt in it and it produces eternally water that doesn't create any lime scale, there's a difference. But the quality is better with these cartridges. The reverse osmosis that we are beginning to see more and more into the coffee market. Calcium carbonate goes into the reverse osmosis, and outside we have nothing. It's the most similar water, the water most similar to the distilled water, because the membrane of the reverse osmosis is so thick, so dense, that the porosity of the membrane is smaller than the smaller ion contained into the water. So everything is bounced back to the drain. And on the other side of the membrane, we have a water that produces a fantastic ice. No scale buildup, of course, no salts, no solids inside the water. The mineral levels completely disappear. It's the best possible ice quality, high capacity. The chlorine, let's take it from the other side. The membranes, those thick and dense membranes that guarantee the performance of the reverse osmosis, can be affected by or can be destroyed by the chlorine. So we need to stop the chlorine, the disinfectant, before the water goes into the reverse osmosis with an activated carbon cartridge. Very simple, very cheap. Last but not least, because it's still the most used system to filter the water, especially the other side of the ocean, wherever you see in the USA an ice machine, there's a polyphosphate cartridge connected. Calcium carbonate into the water. Outside the cartridge, we have still the same quality and quantity of calcium carbonate summed up with polyphosphates. The polyphosphates are a substance that create a protective film inside every place of the machine where the water is passing through. That substance is so slippery that for the calcium carbonate, it's impossible to attack and create lime rock into the machines. But you are adding minerals, you are adding substances to the water. So in this case, we have no scale buildup because it works, very high capacity, because the cartridges, even small ones, they with polyphosphate inside, they make up to 60 or 80,000 liters capacity. Easy installation, like the other cartridges, the decarbonizing ones. Limited space needed. They control the disinfectant as well because they have activated carbon inside. But the mineral levels increase, so the ice is very turbid. The ice is fast melting compared to the ice made with the reverse osmosis or the decarbonizing cartridges. And there is, on top of it, the necessity of periodic cleaning of the machines because the sludge, the film created by the polyphosphates can block, especially the tiny passages of water. So, which system? We are coming now to the end of my presentation. Which system will protect the machine and make a good ice quality? I started with a question, with two questions. I finish now with another question. What is for you a good ice? We have to ask ourselves the question, what do I want from my ice machine? Do I want quantity or do I want quality? If I want quality, if I want ice for, I don't know, for the fish market, it's okay to have quantity. The quality doesn't matter. So a softener is fine for me. If you have to serve ice into a discotheque where everybody are, where it's dark, let's say, yeah, drunk in my case, on drug, some others. Or even a pure activated carbon cartridge can do the work because you just take away the bad taste of chlorine or disinfectant and you keep, let's say, a bad quality of ice, but nobody will notice it. If I need quality of ice, and I'm looking at Michalis, if you need quality, in my opinion, it's decarbonization, and if I need a top quality, I need a reverse osmosis. I hope that every slide that I presented to you stimulated some questions that maybe you want to ask me in the hours that we will spend together after my presentation today, this afternoon. I'm here for you. I thank you for your attention and see you later.
Thank you very much, Sergio. Now it's time for Scotsman with our coffee ambassador, Michalis.
Thank you, Simone. Grazie mille. So, Sergio, thank you very much for this amazing presentation, because I believe that before ice, we need water. So if we don't have the ability to understand what's the important things of the good water for the ice, then we don't have a good quality of ice. And this is the most important thing. So today I will try to be fast. So I will try to tell you a few things about the good quality of ice and why is it important. Ask me. You are living in the same, let's say, Mediterranean Sea, so we are drinking a lot of cold drinks, and let's start with the culture. So according to our country in Greece, if we count down all the drinks through the years that the Greek people are ordering in a coffee shop, because we are talking about coffee, more than 70% of the yearly drinks are cold drinks. So we have, if you visit Greece, for example, we have Freddo Espresso and Freddo, you have the Sekerato, for example. So most of the drinks, they're drinking cold drinks, even the winter. So the ice for us is the most important thing, and that's why I would like to speak about the ice important things. So why we prefer the cold drinks, especially in our countries, even in Italy. For us, a lot of we are taking a lot of refreshing notes with this weather, for sure. We are feeling different sensations, especially when we are drinking coffee. The coffee flavors change more on the acid side, so we're taking more acidity from the flavor perception of the coffee. Then this is in our mind because it's not truth, but for the customers it helps to cool down the body temperature. For the coffee, because we are trying to freeze our coffee immediately, like when we are making a Freddo or when we are making a drip, cold drip, brewing on ice. So we are trying to encapsulate all the aromas immediately, because when you see, when you are making a brew, for example, you can see all the steam coming up. So all these steams also take some aromas. If we are trying to freeze our coffee or the hot drinks, the hot liquid, immediately, then we encapsulate all the aromas of this liquid. Okay, so this is very, let's say, important when you are doing a cold drip at your home, when you are brewing over the ice. And then you have more duration time. For example, if you like to drink an espresso, you need like 3 minutes, 5 minutes, then all the magic things are gone. So with ice, you have more duration in time according to the flavor characteristic of the drinks. Then we have to speak about the dilution. Why is important also in the coffee industry, but more in the bar industry. So according to the bar skin, the most of the bartenders, they would like to have some dilution inside the drinks. So, for example, because you are drinking Negroni, it's one of my favorite cocktails. When you are doing the stirring method, you need to have 15 to 20% of dilution. If you have more, then you have a lot of water inside your drink. If you have less, then your drink maybe it's a bit bitter, but you don't get the balance. For example, if you try to drink a Negroni, but with the ice balls that you can't take water from this, you will see that you don't have the balance of the drink. So you need some water inside your drink. So the water that we need usually it's 15 to 20%. Some of them they are telling 25 is it's more, but for me it's like more on the watery side. So I'm losing all the magic things of the texture of the drink. So if you don't have good quality of ice, then, for example, if you made your ice at your home, you will see that the ice it's gone through the time. Like it's very fast, it's melting. So you are losing all the magic things of the flavors because you have a watery drink, a watery cocktail, a watery coffee. As I told you before, you can use also the stainless steel ice, but you don't have the balance. And the most important thing is when you are using this, the duration in time is like less than the normal ice. And because I have tried to, in my competition, to make an ice, but in very cold temperature. So I took the ice, I put it in the dry ice, inside the dry ice, so minus 68. So the ice became like a rock. So I put it in my drink. I started stirring and shaking and everything. But I didn't took any of the water. So my cocktail, it was totally different. I didn't took the right flavor and the right balance of this cocktail. So my opinion is this is nice, but you are losing other things. So you don't have the balance of your cocktail. You will see also here, we have made, let's say, the ice, how is melting through the time and the degrees. So according to the ice that you are putting inside, if you go in a bar, usually you can see the bartenders, the good bartenders, they are trying to have a glass full of ice. The ice is from the bottom till the top, because you need a big amount. The bigger amount freeze immediately the liquid, the small amount. So if we're talking about a good amount inside your glass is 60% of ice and 40% of liquid. So the big thing is stronger than the less thing. So that's why we need large cubes, we need more ice inside the drink, we need more ice instead of the liquid. So we don't have to see a glass of gin and tonic or Negroni with only ice off top. This is not a good drink. So as a customers or as coffee lovers, when you're ordering a cold drink or a cold coffee, you have to see the glass and you can understand if they're curious about their drinks. In other case, they will lose all the flavor characteristic because of the dilution through the time. And of course, you're losing also the temperature because of the surface. A big ice have less surface, so have less contact time with the liquid, so it takes longer to get melting. So now I will talk about the shape of the ice. You can see a square shape, you can see the cylinder, you can see the balls, you can see a lot of different type of ice. Because we are doing a lot of experiments, especially in the previous theme, the dilution, we have tried a lot of things. So here we have some things that the size matter for the ice, but I would like to tell you something. We have seen sometimes when we have the square, for the bartenders that they are doing a lot of cocktails with using the shaking method, then they have a lot of dilution. They have a lot of corners, so the shape, it doesn't help the ice to be strong. If you see with the cylinder, like the gourmet, for example, the gourmet ice from Scotsman, you will see that we have less corners, so this helps us to have less breaks inside the shaker. So we have less water inside the cocktail. So we have a cocktail with a good quality of texture. In other case, it's a disaster. So the size and the density of ice determine the dilution factor, for sure. The type of the water make the difference. As Sergio told, for us, the most important thing is to have good quality of water. If you have the best machine, like, okay, you are going to buy the La Marzocco Strada, the best machine, then the best ice system technology, and you don't have a good quality of water, then it's a disaster. It's like involve all your money in a good products, but without good base. So also the freezer plays a huge role for us, because, for example, in the gourmet ice system, where we are using all the capsule on the top, then we're using the spray system technology. So we would like to have a powerful freezing system on the top, because we are spraying all the water from the bottom. So the spray system give all the water to the capsules, and the capsules start to freeze the water from the sides to the middle. So we need the power of the freezer, and this helps us to make an ice without bubbles inside. So it's stronger, because starting freezing, no bubbles inside, because if you put just the water in your refrigerator, you will see a lot of bubbles in the bottom, a lot of minerals in the bottom. So this is not good for, let's say, the strength of your ice. Okay, so we're using the freezing system technology by the spray system. So all the bubbles goes out, all the minerals goes down, because the minerals are heavier and denser than the pure water. So at the end, you will see at your machine like something like sand, like a yellow sand, is some of the minerals. This means that if you count the water after the spray system, you will see that the water have less TDS, but I will tell you a bit about TDS. So for sure, we had to invest our money in a good quality of ice system, and for sure, we can invest our money in a good filtration and in a good quality of stuff that we're working every day. So what we can do, for example, in Greece, here I have, I have some of the daily things that we are working. For example, espresso and filter coffee, cold brew, syrups and alcohol. For example, for the espresso, because we have a lot of solids, dissolved solids inside, but the coffee comes out from 93 degrees, so when it's going down, it's like 70, 69, it depends from the machine and also from the barista. You have to put your espresso in my country over the ice. So you need to have less dilution and you need to freeze it immediately. So if you have an ice with a lot of minerals inside, a lot of bubbles, with let's say bad quality of water, with not a lot of strength, then you're losing all the texture from the espresso. That's why, for example, in my place where we are using good quality of ice, a lot of ice, we're spending a lot of ice because we would like to create the best experience for our customers for the flavors and the texture experience. So then it's the filter coffee, the cold brew. We are made the cold brew in the cold brew tower by using only the ice because we would like to have a pure and clean water. So because we're using the spray system technology, as I told you before, and good filtrations, we are taking only the pure and the clean water. It tastes neutral, not any flavors coming from the water. And this is very important because we're talking about here in the cold brew, we're talking about a contact time like 8 hours, maybe sometimes 10. So we're talking about an extraction that takes a lot of time. So we have big contact time, and this means more solids inside the last liquid. But if we're making an extraction of the coffee with a lot of solids coming from the coffee, then maybe sometimes we have a lot of dry effects at the end. We have a lot of astringency on the texture. We have sometimes the bitter flavors coming from the caffeine. And we are trying to brew it always with Simone, with the water coming from the ice, because here in the tank we have always the temperature of close to 0 degrees, because according to the physics, on the bottom you have the less temperature of the tank. So usually the first drops are close to 2 or 3 degrees. And you have, at the end, you are taking, let's say, more sweetness, more acidity, but without taking a lot of bitterness and dryness, because this is the problem sometimes of the cold brew. And for us, it helped us to have always the consistency, because we're talking that we're brewing every time with the same temperature of the water. If we're changing the temperature, then we have totally different flavors at the end. So, quality of coffee, for sure. The quality of water, this is the most important thing. Also for the, let's say, the life of the machine, the espresso, and also the ice system. The temperature of the ice. Some people, they are taking the ice, they are putting in their bars, they are letting the ice there for 6 hours, and then they have some small ice after 6 hours. So they are trying to use this. You don't have to use this. You have to use always the good and then the fresh ice. You have to use the ice that is it's on the size that you made it. In other case, you don't have a strong ice. It's not a problem of the machine. It's a problem because you let your ice over there for 5 or 6 hours. So then is for us the syrups, because ice, for example, when we're putting syrups on the cocktails, help us to have more body in the cocktail. And then is the balance. The balance coming from the dilution of the ice. We don't need a lot of dilution, but we don't need less dilution. So we need 15 to 20%. And then is the customer information. As you told me before, what is the good quality of ice? How you can understand in a bar that in front of you you have a good cocktail with a good quality of ice? Because of the, first of all, of the shape, then about, you know, the visual appeal. If you see a lot of white colors inside, or if you see a lot of bubbles, then you will understand, you have the ability to feel that, okay, this is not a good cocktail. Even if I have the most expensive alcohol, let's say Japanese whiskeys, I don't know, something that is very expensive, even if I'm using the best product and the best stuff in my bar, if the customer see a glass, but with an ice, with white color, with a lot of bubbles inside, maybe with, I don't know, the shape is not very, very good, then what's the reason to spend all your money on making, on buy the good equipment? I have to finish, huh? So, as you told before, Sergio, about the TDS help us to make the good quality of ice. According to my opinion, the best filtration is the carbonization. Okay, because you are using all the water coming from the water source. You are taking less minerals, and then the spray system technology helps you also to have the some minerals down. So you are taking a good quality of ice. I like reverse osmosis, but you know, if you can use the water that's coming from the other side, then is the best. But if you are going, because some people they are going to throw this water, then is a disaster. So if you are using reverse osmosis, just find a way to use the water that is coming from the other side. Okay, so the more TDS that we have, the less strength we have inside our ice. The less TDS we have, then we have the strong, the hard ice with clean and clear and no flavor inside ice. So this is very fast. I told you about the bubbles. I told you about the soft water and the hard water. So for ice, the best friend is the soft water, because you have all these things inside your glass. If you want to ask me something, we are trying. I told you about the reverse osmosis, but for us it's very important to be friendly to the environment. That's why we're trying to use the X-Safe, for example, to clean the machine. We're using also the ecosystem technology because, you know, sometimes we have to protect our planet, not only because we're ice system factory, but also in the way of cleaning the machine. So if you want to see the X-Safe system technology, how it works to clean your machine from inside, because this is the hardest part of the bartenders. If I'm going to a bar and I will open the machine and check it, you will see that it's full of things inside. So this is the hard part of a coffee shop or of a bar. So that's why we have we are trying to develop new things to have always a clean and clear machine to produce the perfect ice for the customers. That's it. Thank you very much for your time. Good.
Allow me just to say one thing. I agree completely with what Michalis said. It's with typical Italian precision that I forgot to tell you one thing before. The sodium chloride, that means the sea salt water, the water with some sea salt in it, cannot be removed by means of cartridges or softener. So because of let's say, an ethical problem, like Michalis said, the reverse osmosis produces 1 liter of very good water, throwing away in the drain the same quantity. So today, with all the problems that we have of not raining enough, the reservoirs of water that are decreasing their level, it's really a bad thing to waste water. So I would suggest to use decarbonizing cartridges because they use 1 liter to make 1 liter, and use a reverse osmosis only in case you have salty water. Water that tastes like the water for the pasta, for the spaghetti. Greek islands, Italian islands, coast of Sicily, all the small islands, the south of Italy, Calabria coast, Barcelona, all the costa, Costa Brava. There's no solution for that. In that case, I'm really sorry to say that we have to use a reverse osmosis. So there are some customers of BWT, for example, that you have to be really thinking very much forward, because there are some customers, especially the Danish, the Norwegian customers, that build their coffee shop starting from the water. So they place a reverse osmosis and they send the wastewater into a big reservoir that they use to for the water for the toilets, for the lavatories, or to, I don't know, for the garden. In that case, you have the complete quantity of water used while you are producing good water for the ice and for the coffee. But if there is no need of purifying the water at such level, if you have not salty water, I would say don't use it. And thank you for allowing me to say this.
Thank you, Sergio. Evcharisto Michalis. As said, we are going to have the chance to try some of his creations, hopefully with the optimal ice cubes, because we have both the Scotsman machine and also, of course, the BWT water filtration system. As next, we are going to have the presentation from side of Accademia. So we will start with Marco, who will tell you a little bit about frozen coffee and roasting. He's the roasting and coffee specialist at Accademia del Caffè Espresso. And the other part will be done by Simone. I will make you the microphone in a second. Don't which will be more related to extraction and serving of so-called frozen coffee. I forgot to say before, sorry, we have many people following us in a live stream. So in case someone has questions, please write them into the chat so we can cover it as we have all the representatives here. And of course, for the ones who are here in presence, they can ask then or directly after the lunch or also like in between. You know, asking doesn't cost anything.
Hi, everyone. I want to start with a super quick example. Of course, everybody in the morning knows that he needs to dial in his own coffee at the coffee shop. This is due because coffees are really susceptible to temperature changes. So, of course, when the barista dials his own coffee in the morning, try to achieve the perfect balance in his own cup. Of course, after several minutes or several times, the burst can be warmer, or even the environment can be warmer. So the result in the cup will be different. This is due because coffee as being susceptible to temperature changes, can even be different in ground size. We always need to consider that coffee is really brittle. It's a natural product. Then once it's grounded, doesn't have a even distribution of the grounds. That means that the coffee has been chipped down into small pieces, and there's no piece equal to another. Of course, that means that the coffee needs to be well distributed, so that means that the bursts are higher in quality. Of course, during the roasting, coffee starts to be consumable, and we always need to consider that what we perceive as aromas, so the aromatic part of our coffees, is composed of volatile compounds. So there are compounds that are can really be lost in the environment around. Of course, the more gases we lose into the environment, the more the coffee starts to age and we start to lose all the aromas and the aromatic part. Of course, coffee, the major thing that can damage our coffee flavor profile is the high temperature, because of course, with high temperatures, all the gases start to be released much quicker. The light, the moisture, and the oxygen. Oxygen, of course, starts a process of oxidation into coffee. So, of course, even coffee in this case start to taste like stale, much more compared to the fresh one. So for that, in order to have a coffee that can last for a longer period of time and can even be more even in terms of coffee served, we found a protocol of freezing coffee. Of course, freezing wouldn't halt completely the aging process, but of course, coffee can last much longer compared to leave it in a room environment. Of course, freezing means that it can preserve the freshness as long as possible. So it means that coffee can last for a longer period of time, as well as can improve the grinding quality. This is because basically as the coffee is frozen down, the cell structures start to be much more brittle. So once we start to grind the coffee, we have an even distribution compared to the room temperature one. If you go to the next slide, as you can see from the graph, if we consider the purple curve, no, sorry, the red one, so the one at 20 degrees, the distribution of the grounds is not that even. So as you can see, the peak is not as steep as the others. This means that it can produce much more fines compared to the other temperatures. And of course, we can have a lot of issues during the extraction. If we take the purple line instead, the one we consider as freeze coffee, so the coffee that's been placed into a freezer, so we are now around minus 19 degrees. In this case, the curve is much steeper, so that means that the distribution of the grounds is more even and is well centered in the ground size we choose for our coffee. Of course, the grinding quality, it decreases proportionally to the temperature. So that means if we put our beans in liquid nitrogen, so we place it to a minus 196 degrees. In this case, the production of fines is even lower, so our coffee is more consistent in terms of serving. Of course, a question everyone can think about is how frozen coffee can change the cell structure. Because as we know, if we freeze fruit, like in a freezer, so without any blast chiller, we can ruin completely the cell structure because of course the water takes more space compared to water. So of course it's gonna break down all the cell structure. During roasting, there's not this issue because roasted coffee contains just 2% of moisture. So of course the amount of free water that we have in roasted coffee is such a low quantity. So in this case, there's no changes in terms of cell structure, that the cells are not destroyed by the freezing process. So that means that all the notes are well preserved even in roasted coffee. Of course, to freeze coffee, in order to be consistent in the coffee we serve, we need to define a protocol. So basically, we need to define some rules to follow every time we freeze a coffee. For example, from our side, we decided to have a protocol depending on the roast color. Because of course, the darker the color of the coffee, the more time it needs to outgas, so to lose some of the aromas, or some of the gases that are contained within the beans. From our side, we decided to place all the coffee we freeze in pre-dosed jars, pre-dosed test tubes like this you can see in the picture. Basically, because of course it's easier when you need to serve your coffee because you have a pre-dosed one. And it works even because we have a little to no space, head space on the top of the test tubes. So there's no oxygen inside the test tubes, and the oxygen wouldn't start to oxidate our coffee. As we were saying, we have a different protocol depending on different colors. For example, every time we roast a coffee, we let it dig out gas in a Hopper environment, so just leaving it in trays for 24 hours. After 24 hours, we stock them in coffee bags in order to have less oxygen that start the oxidation process. For lighter roast, just think about filtered roast, for example, we usually let the outgas in closed coffee bags for 3 days. For medium roast, for example, espresso, single origin espresso, we let it degas for 5 days, even in this case in closed coffee bags. For darker roast, so coffee that can reach even the second crack, we let it degas at least 8 days, because of course the amount of gases we created within the beans is much higher compared to lighter roast. Of course, for after this timing of waiting, we pre-dosed all of the coffee in pre-dosed test tubes that we did before, and we always include half a gram of coffee more in order to purge our burrs before to grind it.
Okay. Thanks, Marco. So why do we freeze coffee, and is there any good result in that? It's very important when we talk about flavors in coffee to focus on the volatile part that is very delicate, and it's the one we really want to catch in our cup. So we are talking about chemistry, esters and terpenes mostly. That is something that is very affected by high temperature. So freezing coffee for sure keeps more volatile part. Meanwhile, we have seen that the acidity level always grows, is always enhanced. And so the roaster gotta know that and make a decision that can balance that higher acidity, or the barista can do the same. That happens with all the coffees we tried, and you know, is not the best thing to catch, but there's the way to balance it. We have the chance here to work with a company called CDR Food Labs that makes instrument to test food in general. We are helping them to develop an instrument to analyze the chemistry in coffee. So we had the opportunity to dig deep on that, and we made a good amount of tests to understand if there are any differences between frozen coffee and regular coffee, non-frozen coffee. And we have seen that there's no difference at all. The tests are made both on roasted coffee and also on beverages. And in both cases, there weren't differences in terms of total acidity. And in general, no difference is spotted at all. Another good question: how long can we keep the coffee once frozen? About 1 year of shelf life, but of course we have seen that there are differences between coffees and coffees. We haven't enough data to tell if it's the density that changes. Some coffees are almost perfect after 1 year. Some others seems to be more affected by freezing and are good till 2-3 months, no more. We're just waiting to get solid data to to understand what was the difference between these coffees. So the trend in the market is going on in many different ways. What you see that in the picture is just simply a frozen pour filter. We are playing with that. We made some experiments, and it is a way to the thermal shock preserve the volatiles and the more delicate notes. That is just a very simple way that everybody in their coffee shop can try, maybe with a blind tasting, even if the temperature, of course, will be easier to recognize. Another tool that appeared in the market is the one we've seen in the picture. It's called the Paragon, and is basically a tool with an aluminum sphere that got frozen before the brewing, and the purpose of this tool is to get more volatile part. That was developed with Zurich University of Applied Science, and they made very solid data, and they have seen that there's the 40% more volatile in a cup extracted with Paragon than in one with a regular extraction.
I'd like to add something, because if you think about freezing the equipment, means that, as we were saying before, all the aromatic part is volatile. So if we freeze our equipment, all the volatile are dissolved in our water immediately, so there is not lost in the environment. So of course, that's why we have a bigger amount of aromatic notes in our coffee when we use frozen equipment, and even in terms of long lasting of the beverage. So the beverage, even as it starts to cool down, it will maintain more the aromatic part, and it will taste more balanced even as the coffee starts to get cold. So it works even in espresso. We all know that espresso needs to be drunk when it's hot, because usually it starts to be super unbalanced when the coffee starts to cool. Using frozen equipment in this case would make the coffee last for a longer period of time. So even for espresso and filter, we'll have a much more pleasant cup in an overall sense. So in the whole, in all the temperatures you can find in coffee. I don't know if you have any questions or any curiosity, any doubt.
Just something related to the shelf life. You said before the shelf life. What about the normal shelf life?
So usually after the coffee is being roasted, it starts to lose gases. So all the gases that are contained within the beans start to be lost into the environment. Of course, we have different tools where we can make the coffee last for a longer period of time. For example, placing in closed coffee bags with valves where the gases can get out, but oxygen cannot get in. So in this way, coffee can last for a longer period of time, but we're talking maximum for 3 months. After 3 months, the coffee starts to taste stale. If we freeze our coffee, we have the chance to make the coffee last for a longer period of time. And for we have tasted till now, coffee can last up to 1 year or even more. And when you brew your coffee and you brew them still frozen, so you don't need to defreeze your coffee before, the coffee will taste like freshly roasted. So we haven't seen any big difference in terms of quality, even after 1 year and a half. So of course, we always need to consider that the coffee needs to be stocked in, as we said before, in pre-dosed jars. But the best way would be having an environment without any oxygen, because even if the coffee has been stocked at -19 degrees, of course, there will occur a little of oxidation still. So we need to find a way to make it last for a longer period of time.
Thank you. It's like one of the projects we are following here, exemplary at Academia, because the coffee industry is evolving very fast. And as you know, all the machinery, all the technology is, I guess, way faster than all the knowledge about a natural matter like coffee. So yeah, we wanted to share this presentation as an example, also to underline that there is not like a general rule. There is always like exceptions because there's simply so many different species and varieties and roast styles and so on in the coffee world. Thank you, ragazzi. And now, last but not least, we will welcome Stefano from Carpigiani Gelato Academy. Did I say it? University, sorry. Yeah, who will tell you a little bit about quality gelato. And then as said, later on, you can try all these mentioned things in person. So I leave you the mic.
Yeah. So, good morning, everybody. Kalimera, since you said grazie a tutti, I repeat Kalimera. So this Kalimera and Efkaristo actually are the two Greek words I know, and that's my Greek. That's it. That's the end. So, by the way, thank you first of all to Nora and to all the La Marzocco and the Espresso Academy for this opportunity. Actually, I'd like to say first of all why we're here. We are Carpigiani Gelato University. We are Carpigiani actually, and there are a lot of similarities, I would say, with La Marzocco, and that's the reason why we started this cooperation together. That has been, I think, about 2 years or maybe more than that. You know? So we started directly, I think, more than 2 years ago. So essentially, La Marzocco started everything from the dream, let's say, you know, in order to make quite emotional, if you want, of two brothers. And that is the same for Carpigiani. They were artisans as well as the two brothers who developed, let's say, who built the Carpigiani. They decided to stay focused for their entire journey into quality, and that is exactly the same for Carpigiani. We have an academy, let's say, as well as La Marzocco as an academy. So actually there are so many similarities, so many things in common that's it quite natural, I would say, to create a merge and to create synergy. And that's why we're here today, basically, no? So thank you again. And I hope actually today you're going to have a better idea, let's say, of what is gelato. Because this is the very first question, no? So even before to start everything, even before to understand what's the difference between gelato and ice cream and all the details and all the specific characteristics, the very first thing is, okay, what is gelato? And actually, the easiest way, I think, to understand what gelato is understanding the simple characteristics of a regular customer that even a regular customer can understand quite easily without being expert. So when I'm talking about the characteristics of gelato, I'm asking you. So I'd like you to reply, actually, you know, when you're going to a gelato parlor, in your opinion, let's say, which are the elements to define high quality gelato? Because when you find out the elements, then you will understand the differences between good gelato and bad gelato. And in general, let's say also the differences between gelato and ice cream, because they are kind of cousins in a way, but they're not the same thing. No, there are differences. So today, actually, we would like for you to understand much better what gelato is, which is the quality when it comes to gelato, which are the elements to define the quality, and what's the difference between gelato and ice cream. So when you pop up in a gelato parlor, what are you looking for? Let's say, if I'm looking for something with high quality, which are the elements, in your opinion, to determine the perfect quality of a gelato? Very easy, yeah? Don't think something like a very low, like a thermos, super easy. Texture? Texture? Here we go. So let's say, basically, you said 2 out of 3. So texture, taste, of course, and then there is another one which is missing, which is a little bit more technical if you want, but not too much, which is the structure. So let me just define quickly what's the difference between texture and structure, and let me define also what's the meaning of good taste when it comes to gelato. Because taste, as we know already, it's quite subjective. So it's quite complicated to determine, okay, this is good and this is not. This is something I like, and so since I don't like that, this is not good, So the point is, in order to define something subjective into something objective, let's say, I think the easiest way to determine a good taste when it comes to gelato actually is the fact that it is immediately recognizable. So that sounds quite obvious, but actually it's not. So many times when you go to a gelato parlor, maybe you try the product, you feel like milk and sugar, for example, and then in the very end, maybe you recognize, okay, that's hazelnut. But actually, when I'm talking about a high quality product, it has to be like, in your face, something like that, straightforward. So you have to immediately recognize this is hazelnut. No matter if it's hazelnut from the northern part, like from Piemonte, for example, or the central part of Italy, like, for example, from Lazio, or the southern part of Italy, from Sicily, from Naples, actually, from Avellino, actually. It doesn't matter the one you prefer. The point is, as soon as I eat the product, I have to recognize, okay, this is hazelnut gelato. And many times, it's not that easy to understand, unfortunately, I'm saying. Let's say in Italy, actually, we have a culture regarding that, and so we are much more focused on this. But especially if you go abroad, it's more complicated to understand properly this, And so immediately, let's say suddenly, actually, is not so obvious as it's supposed to be. So this is the first point. And so definitely this is related to the ingredients. So we cannot make miracles, let's say, I mean, as long as you're working with good ingredients, probably if you do your job well done, let's say, probably you're going to get something good in the end. If you're not using high quality ingredients, then it's quite complicated to get something very good, actually. And this is something I will show you later on. Let's say, oh, no, it's the other way around. I will show you later on, let's say, especially when we're talking about regular gelato and saucer gelato. But this is a speech I'm going to talk about that, let's say, later on. Let's say in the next 3 minutes, by the way, because I cannot speak all day long. Anyway, it doesn't matter actually what's written here. I mean, it's something important. You can read later on, let's say, taking your time and so on. But actually, what is gelato? Gelato is a combination of taste, texture, structure. Texture means we don't want any crystals. We want something smooth and velvety. We don't want any ice crystals, or better, we don't want ice crystal to be too big, let's say. We don't want to fill them. We don't want actually any sugar crystal, or once again, we don't want to fill them. As well as we don't want any fat crystals, okay? So essentially, when I'm talking about textures, I mean, we don't want crystal. We don't want to fill the crystals, let's say. This is the first aim of every single gelato maker. And then actually, when it comes to structure, what is the structure and what is the difference between structure and texture? Actually, structure means not too hard and not too soft. It sounds like super obvious, but it's the reason why we make a 1 month class, basically, like 4 weeks class, basic, intermediate, advanced, and superior, to understand how to manage the structure of our product. We have to control the sugar level. We have to control the emulsion and the fat content in general. We have to control the viscosity. I mean, it's quite, let's say, I don't want to say complicated, but it's quite tricky, let's say this, And so the merge, let's say, the combination of good taste, good texture with no crystal, and good structure, not too hard, not too soft, that makes the quality when it comes to gelato. And from this step, we can immediately understand the first difference between gelato and ice cream. When I'm talking about structure, the structure of a gelato has to be not too hard, not too soft. So what does it mean? It means essentially that as soon as I dig in the pan and I get some gelato in the spatula, I'm not squeezing, pushing, or scraping the product, because it has to be with the right structure. That means as soon as I dig in and the product sticks to the spade, then I have to be able immediately to put on a cone without a bead, without touching it too much. So every time when you go to a gelato shop and you see they squeezing, they touching, that wouldn't be properly, let's say, the right way. But it's entertainment, it's show, whatever. But actually, the best way to manage a gelato is you dig in, you take what you need, you put on top of the cone, and you don't touch it anymore. Because the more you touch, the more you push, the more you squeeze, the more you are, let's say, creating friction. And so basically you're melting the product. You're losing your bubbles, let's say, because there are some air bubbles, by the way, in the product. And you're losing the structure, actually, no? And that is the reason why the structure in gelato is what identifies gelato versus ice cream, imagine. When we're talking about ice cream, we're not talking about digging in, taking the product and put it on a cone. We're talking about scraping the surface. We're talking about scraping until we get, and squeezing also and pushing a little bit, until we get a ball, until we get a scoop, actually, no? And to make it possible, what you need is a different structure. The structure is more compact. The structure is more frozen, actually, because the first difference between gelato and ice cream is the serving temperature. And so, of course, the structure is involved in that. The serving temperature of gelato is -12, -14. Let's say in some Pozzetti counter, the one with the dipping pots, with the lids, it could be also -11, let's say, so it could be warmer. So essentially, the serving temperature of gelato and the serving temperature of ice cream is the first difference between the two. Ice cream has to be served at -18 degrees temperature. Gelato has to be served at -12, -14 degrees temperature. So it's quite immediately understandable, that, as I told you already, the structure is different. Gelato is softer, okay? Gelato is softer, gelato is smoother, gelato is less compact compared to ice cream. And then the second thing is the taste of gelato, actually, it's stronger. And this is physics, basically, it's warmer. So, of course, we get a better perception of the taste. Because when we're freezing a product, the coldness in general anesthetizes a bit the palate. And so definitely, if I serve the product 4 or 5 degrees lower than gelato, the product is going to be colder. And then the perception of the taste is going to be released slower, and so the final taste is going to be lower. But actually, they don't want to get less taste. When I say they, I mean the ice cream makers, no? I'm talking about, they don't want to get something tasteless, of course, no? They want to get something tasty anyway. And that's why they use one of the best vehicles, let's say, to get taste in the product, the fat. This is another big difference, let's say, between gelato and ice cream, no? In the ice cream, in general, we have almost the double percentage of fat compared to gelato. Let's have a look on some. I didn't want to spoil, that's why I didn't go through, no? But look, talking about the fat, normally when it comes gelato, is about the one on the left, let's say, is about 0 to 10%, okay? Maybe, let's say, in Bologna, where we're like a little bit richer, it's just a little bit higher, maybe, but not too much, no? But when it comes ice cream, we're talking about almost 20%. Sometimes, let's say, in the US, they define the quality of the product according to the fat content. So the higher is the fat content, the higher is the quality, let's say, We don't think properly this way, let's say. Even because, imagine, it's possible, and today we're going to show you something, it's possible to create some gelatos, water-based, let's say, completely fat-free, like the sorbets. If we make a fruit sorbet, still a gelato actually, but it's completely without fat. Later on, we're gonna make a coffee sorbet, and actually the fat percentage is almost, I don't wanna say irrelevant, but irrelevant actually, just for you to understand in terms of the calories, absorption, it's almost nothing, okay? So it doesn't matter actually, the fat content. I mean, it's important, of course, but it's not the crucial point to define the final taste, And the reason why it's not that important is because the temperature is higher. And so we have a better perception of the product itself, of the taste itself, okay? And then there is another factor, as you can see, in the middle, the overrun. What is the meaning of overrun? Overrun means air incorporation. So when it comes gelato, as well as for ice cream, okay, and as well as for many other products like a mousse, for example, like a chantilly or whipped cream and so on, you get some air incorporation. So spinning the product, through the spinning, basically, through the rotation of a beater, let's say, through the rotation of a beater, basically, is possible to incorporate air bubbles. The air bubbles actually helps a lot when it comes the fluffiness. So the product actually is getting fluffier, and lighter. It helps a lot when it comes the mouthfeel, so the perception. So through a good air incorporation, you get less cold. The filling actually is less cold because it's not possible to freeze the air bubbles at the temperature we're working with. We should go at minus 200 or lower, for example, So that means that the temperature we are working with, the air bubbles are not frozen. And so that makes our product warmer. But the problem is when you exaggerate with the air bubbles, when you exaggerate with the air incorporation, and then, of course, you're going to dilute the taste. You're going to lose taste, okay? So imagine when it comes ice cream, and in general, let's say, as you can see in this case, industrial product, what they need actually is something that has to be kept and served at minus 18, minus 20 degrees, because minus 18 is the perfect temperature to stop bacterial reproduction, and in this way, keeping the product and maintaining the product for a long time. So when it comes ice cream, that's what they need. They need long shelf life, and they need a product that is ready to go immediately after you extract it from the freezer. So how can they make the product like that? They have to increase the air bubbles in. They have to increase the air incorporation. And that's why you can see the overrun is 80 to 120, sometimes higher, And in gelato, actually, the air incorporation is lower because the higher is the overrun, as I told you, the more we lose in taste, okay? That's why also sometimes when you go to the supermarket and you will see a liter, not a kilo, a liter, because they sell in liter, because they are smarter, let's say, economically wise, So when you see a liter of ice cream, let's say industrial ice cream, that costs about €4, and you go to a gelato shop, actually, and they sell per kilo, and they sell at 20, maybe 25, in Bologna now also 25, 26 euro per kilo, you can understand where is the difference, actually. Apart from the ingredients, in the one you can find on the industrial market, so on the supermarket, actually, you got 100, 120% air. That means nothing. So half of the product actually is nothing. That's why it's so cheap, because so far, actually, the air is quite cheap, let's say, it's for free, So that's why it's cheaper, the product. That's why they can manage actually to sell and to serve these products, so cheap, When it comes to gelato, it's not like that. When it comes to gelato, actually, we want less air incorporation because, we want some fluffiness and we would like to get something a bit warmer in your palate without exaggerating. Otherwise, the product is going to lose taste, okay? And as I said, taste is one of the crucial, let's say, fundamental parameters, elements, let's say, to determine the quality when it comes to gelato. Now, so which are the characteristics of an artisanal gelato? So as I told you, the ingredients has to be fresh. This is quite obvious, but this is very important as well. That's why it's possible to use fresh fruits. That's why it's possible to use fresh milk. Imagine, once again, compared to the industrial market. If we have to get every day something like tons, let's say, of fresh milk every day, then it's much more expensive because they have to check the temperature, the pH. The milk has to arrive in a thermostatic way, so basically with 4 degrees temperature continuously, That's why most of the industrial markets, the industrial factories, let's say gelato factories, they make gelato starting from reconstituted milk. That means they start from water and they add milk in powder because it's easier, let's say, to manage the water and it's easier to manage the milk in powder. And then if they know how to balance a recipe, that means basically they know to reach a precise, let's say, sugar content, fat content, and so on, the final texture is quite similar in a way, but definitely the final taste is completely another planet, okay? And that's a big, let's say, plus we have versus the industrial market. So the ingredients, definitely. The fact that we don't need a long shelf life. That's another easy, in our way, let's say, from our side, it's easier for us to manage fresh ingredients because we don't have to consider 2 years shelf life. Gelato actually should stay in a cabinet, in a pozzetti counter for 3 to 4 days, maximum, let's say, Of course, the fresh one is the best. Nothing to say about it, But 3, 4 days, not 24 months, you understand? So that's why, actually, we have to use the fresh ingredients. Gelato has to be as fresh as possible, That's definitely another element, The flavor, of course, and then the sale, the advertising, and so on. So basically, when we're talking about artisan-style gelato, we can make regular gelato, traditional gelato, the one you can find normally in the cabinets, in the showcase, or in the pozzetti counter, or soft-serve gelato. And actually, this is something I would like to underline for just 1 minute, in order for you to understand that most of the time, when it comes soft-serve gelato, you connect, your link is junk food, most of the time, I mean, not all of you, but most of the people, let's say, no, I don't like it, it's junk food. It's not like that, actually, I mean, imagine what we have over there is a gelato machine. Depending on what I'm putting in, I'm going to get in something amazing or I'm going to get crap, And this is the same also for a coffee machine, I would say, as well as for every single machine, I'd say. Soft-serve machine actually is a machine. So depending on what I'm putting in, I'm going to get something amazing or I'm going to get something junky, let's say, And with a soft-serve machine, it's possible to make whatever you want. From not just frozen yogurt, vanilla, or chocolate, as you see 90% of the time. You can make a pistachio sorbet, you can make a tiramisu, you can make an amazing gianduja, you can make a salty peanuts sorbet, for example. You can do what you want. It's all about the ingredients you're adding in. The difference between a soft-serve machine and a traditional machine is the size, especially. Let's say in a traditional machine, the machine is specifically thought to make large batches, 1 pan, let's say, so 3 liters, 4 liters, 5 liters, When it comes to soft-serve machine, it makes 1 cup. Because the cylinder, it's very small. And so in this way, you cannot produce more than 6, 7, 8 cups. So you keep it fresh. So sometimes it's even better. That's why many shops, not only gelato shops, but also some bars, some pubs, some restaurants, they decided to use a soft-serve machine because I think we all agree that the best gelato is the fresh one. So how can I keep the product fresh all the time? That is a perfect way, actually, So depending on the ingredients you're working with, depending on what you're putting in, I repeat, that makes the difference, not the machine itself, okay? So, here we go. So here you see, this machine on the left is a traditional batch freezer where you can manage to produce the pans, so large quantities. The one on the right is a soft serve. Let's say maybe it's not very emotional, actually, to be honest with you. It's not such a very good-looking machine, but its job is perfect. To keep gelato fresh, it's perfect, actually, So these are the main, let's say, way to make artisanal gelato, traditional or soft serve. So in general, which are the material, which are the elements, you know, to make gelato? Now I'll go a little bit faster. You know? As we said, actually, we have air bubbles, we have water, and actually water is the main ingredients of gelato. And when I say water, I mean the water coming naturally from milk, from cream, from fruit, from eggs. In some kinds of dry materials, you got humidity, by the way, no? And the target of every single gelato makers, no matter if you're making soft serve or you're making regular gelato, is to turn that water, is to freeze that water into small ice crystals. The smaller are the ice crystal, the better is going to be the creaminess, the structure, the texture, the taste, the mouthfeel, the everything. And the question is, okay, how can I get very small ice crystals? So I need a technology to do that. I can't use a regular freezer. What I need actually is a batch freezer. No matter if it's a traditional one or soft serve. What I need is a batch freezer. So I need a machine which is able to turn the water into ice crystals as quick as possible. The quicker the freezing process, the smaller the ice crystals. That's why actually we need a batch freezer where the product in about 6-7 minutes from +4, let's say +5, you know, fridge temperature, you're going to get something like -7, -9. So we're talking about 15 degrees roughly, you know, excursions in about 7-8 minutes, something like that, okay? So basically, but at the same time, we need something dynamic, okay? Because otherwise, you know, you can say, okay, we can use a blast freezer. Yeah, but in a blast freezer, actually, you have a static way to freeze the product. You need something dynamic because through the spinning, let's say, of the beater inside that you can see in this slide here, you have two things. You have a uniform freezing process, because imagine in a static way, the freezing is coming from the outside and going little by little to the central part, no? But if it's a dynamic freezing process, I have equal temperature everywhere in the chamber. And so I have a uniform freezing process. So I have uniform equal size ice crystals. So this is the first thing. The second thing is through the spinning, we get air bubbles. It's like when you whip the cream. The principle is pretty much the same, you know. When you whip the cream, you get air incorporation, and this is the same. So this kind of machine actually is a machine where you get the air incorporation without a pump, but by nature. So when they ask me, can we control the air incorporation? No, it's not possible. It is what it is, actually, you know. Then, of course, we can manage the recipe using some ingredients to help the air incorporation, no, or not, depending on what you want. But in general, it's not possible to decide in the beginning on a paper, I want 35% overrun, for example. It's not possible, okay? When it comes industrial freezer, you can, through the pressure, basically, you can manage the air incorporation. So they can decide how much is going to be the air incorporation, for example, no? By the way, as I told you, the components are liquid, water, essentially. And then we're talking about solids. And when I'm talking about solids, I'm talking about the sugars, fats, proteins, the fibers, the thickeners, everything. Whatever is not water, essentially. You know? And the most important one is not the fat, as they think, let's say, overseas, no? It's the sugars, actually. Because through the sugars, we can manage taste, for sure. Because in general, no, we can say that the sweetness is similar to the saltiness. No? If I use the right amount of sweetness, the product is tastier. If I put it too much, the product is too sweet. And this is the same as well as for the salt. If I put the right amount of salt, it's tastier. If I exaggerate the salt, it's salty. Okay? So definitely with the sugar, we can manage the taste. But especially with the sugar, we can manage another very important character, let's say, in the picture, which is the anti-freezing power. That means super easily, you know, without going too much in detail, you know, in let's say, a deep definition, you know, the higher the sugar content, the softer the product, the lower the sugar content, the harder the product. So you can understand that it's especially through the sugar that I can manage the structure to make it harder or softer, okay? So it's quite, it's not easy, let's say, you know, because if I'm not using a good amount of sugar, the product is not soft enough, but the risk is maybe it's going to be too sweet. That's why we don't use just one kind of sugar, but normally we use many kinds of sugar. And every single sugar has a different anti-freezing power, different capacity, let's say, to make the product harder or softer, and at the same time, different sweetening power. There are some sugar are not sweet at all, for example, no? So don't imagine the sugar as just the sucrose, the one we're using normally, no? There are so many kinds of sugars. And all of them, they have anti-freezing power, specific anti-freezing power and a specific sweetening power. So we can play with them, no? So essentially, gelato is a mix of water, solids, of which especially sugars are the most important one, gas, air bubbles, let's say, and coldness, as I told you. Without the coldness, without the proper technology, it's impossible to get a proper product, no? The main liquids, no, we're using are the water, if you want to make a sorbet, like a fruit sorbet, or in general, a water-based gelato, even a chocolate sorbet, a pistachio sorbet, a coffee sorbet, for example, or dairies, milk and cream in general, no? Of course, the coldness is extremely important, and so the technology related to the coldness, no? As I told you, with this machine, basically you can get the right texture, the right overrun, the right performance in general of gelato within 7-8 minutes. So it's very, very fast. And then we got sugars, we got cocoa beans, we got eggs, we got nuts, we got whatever actually. So we can make gelato with whatever you want. And when I say whatever you want, just for you to understand, we made gelato also with crickets. You know, the crickets, you know, okay, for example. So let's say, not my favorite, to be honest with you, no, but it's possible, no? So really, you can use what you want, okay? Yeah, you can use spices and so on. And then, of course, as I told you, you can decide, I can make milk-based gelato, much more, let's say, traditional, no? And I can make whatever I want, from, let's say, custard gelato, vanilla gelato, hazelnut gelato, pistachio, chocolate, whatever. Or I can decide to work completely water-based, and I can make fruit sorbet, chocolate sorbet, pistachio sorbet, coffee sorbet, and I can play completely dairy-free. And nowadays, let's say dairy-free, low sugar content, or no added sugar directly, and so on, are quite important, let's say, trends, direction of the markets, and actually we have to be aware and focus and able to create products in those directions, okay? What we're gonna do today, and then we're gonna finish, okay, this is just quickly the production flow. So of course we have to find the selection, the ingredients, sorry. We have to formulate the recipe, and this is quite tricky because it's about, let's say this, calibrate your recipe using precise percentages of sugars, fat, proteins, and so on. And so you have to balance a recipe, not just in terms of taste, but also in terms of the configuration and the composition itself, because we are working actually below zero. Compared to all the other desserts in general, no, we have these gap, let's say, and if you don't balance a recipe properly, if you don't calibrate your recipe properly, then the gelato is getting hard, or it's getting soft, it's crystallizing, it's melting, and so on. So you need to balance the recipe. Then you have to pasteurize the mix. That means you have to kill bacteria, but not only. To kill pathogenic bacteria, that means pathogen able to create disease, no? But not only, the pasteurization helps also in melting the sugar, activate the thickeners, getting good hydration of the proteins, and so on. So it's not just a matter of, I want to kill the bacteria, okay? And also changing the taste. If I'm adding raw egg and sugar together, I'm not going to get a custard. I have to cook it if I want to get a custard taste. You understand? So we have the pasteurization that helps in many ways. The aging, so as soon as you finish the pasteurization, so as soon as you finish to cook and to cool down the product, then you have to leave it age for at least 1 night, no? And a perfect example is not just gelato, it's also tomato sauce, or if you are from Bologna as me, ragu. I mean, if you make ragu, something that has been stressed, no, with a thermal shock, cooking it, no, for quite a long time, then if you let it stay resting, let's say relaxing, you know, for one night, then the taste the day after actually is going to be better. Okay, and this is the same for pretty much everything, you know, and also for gelato. So then you can add the flavoring, no? You can decide which flavor you want to make. And then there is a compensation that I will explain you in a few seconds, and then I almost finish. And then batch freezing, hardening, that today we're going to skip because we don't have any necessity to sell the product and to keep the product, because I guess you're going to finish quite immediately. And so basically, we don't need that, but hardening means as soon as you extract gelato from the machine, gelato starts to melt, because the first impact with the reality is room temperature, you know? And so the surface of gelato starts to melt. We have to stop this process as soon as we can, and that's why we have to keep it in a shock freezer, in a blast freezer, let's say, in order to create this crust that stops the melting. We're going to skip it today because I think we don't have time. Let's say it's going to run immediately, basically, you know, without melting, actually. And then showcasing and selling, you know? So what you can do if you want to make gelato, you can make every single recipe from scratch, or you can decide to make a basic preparation. The basic preparation is a basic preparation where we got the common ingredients. So milk is in every single gelato, cream is in every single gelato, sugars and so on. So you can decide to make a basic preparation, like in this case, which is called white base, since it's white, okay? Then what you have to do is, or a sugar syrup, if you want to make a sorbet, for example, no? That could be your basic preparation to start with. And then, for example, this is one of the recipes we're going to make this afternoon. We're going to start from the white base, which is milk, cream, sugars, and so on, that's been pasteurized, aged, and rested properly. No? Some almond, which in this specific case is been turned into a paste, where paste means that the almond, as well as the hazelnut, the pistachio, whatever kind of nuts, and also chocolate in a way, cocoa beans, for example. What they do is they roast them, they crush them, they mash them, and they refine them using some cylinder, let's say, some squeezer, basically, in order to reduce the size of the particle down to 20 micron sizes, something like that. So you don't have the perception of the particles, basically. And the reason why it's better to use this form rather than the almond itself is because you're going to get a better distribution of the product in the liquid mix, so in the base. So the product is going to be tastier. The emulsion is going to be more stable. The color is going to be much better. That's why it's better to use a paste directly. And then, as you can see, we're using some sugar syrup again, okay? The very last minute, and then I finish, guys. As I told you, sugars are extremely important when it comes to gelato for the structure. If the white base has this sugar level, if I'm adding some almond, hazelnut, pistachio, whatever it is actually, they have no sugars almost inside. The sugar content in the nuts, it's very, very low. So when I add some almond, hazelnut, pistachio, whatever it is actually, to the base, I'm dropping down the sugar content. That means the product is going to be rock hard. So how can I return, let's say, to a proper texture and structure? I need to increase the sugar level. That is called compensation. No? Remember before there was compensation. That is the compensation. That's why today you will see the recipe made of not just the white base and almond, but white base, almond, and sugar syrup in order to get the proper final texture. Okay? This is the first recipe, and we're going to serve it together with coffee. So we will decide together later on which one in order to get a perfect combination. And finally, this is the very last slide. If you want to make a water-based gelato, so if you want to use water directly, if you want to make a fruit one, a fruit sorbet, you can go up to 75% fruit. We made some mandarin sorbets, amazing mandarin sorbet with 75% mandarin juice, no? Where 75% means in 1,000 grams, 750 grams are mandarin juice. So a lot of mandarins, actually, no? That is amazing, okay? Some other fruits, like lemon, you need less because it's very strong, no? So you don't need to exaggerate, for example. So depending on the taste of the fruit, you can decide then the fruit percentage. And this is the recipe that we made regarding the coffee. So actually, it's been cold brew. So since we didn't want to cook anything, we didn't want to pasteurize anything because the product has been cold brew, and we didn't want to affect the aromatic notes. We decided to make the product completely with no pasteurization. Let's say just blending all the ingredients together, no. And what we are using actually is the sugar syrup to get the right sugar content and so the right structure. In order to get a little bit better body, let's say, you know, something a bit rounder, we use this kind of prebiotic, natural, and very healthy fiber called inulin, native inulin, okay? And then in order to control the water mobility, in order to avoid to get big ice crystals, it's important to use some kinds of thickeners, which are perfect actually for the gelato making. That normally we call stabilizer because it's a blend, let's say, of different thickeners, no? Mainly locust bean gum and guar gum, for example, or tara gum actually, okay? So these are the ingredients. We're going to blend them all together. We're going to pour in the machine, and in about 6-7 minutes, the product will be ready to go. Okay? That's it. That was the very, very last part. No? So at this point, yeah? Yeah, you have a question? Yeah, of course. Yes?
Do you know, or is there like a survey which is like the most favorite gelato, like the most favorite taste in Europe, Asia, whatever? Is there like a tendency or no?
So let's say in general, chocolate and vanilla, the most, can I say, basic ones are always very appreciated, no? There is especially, let's say in Europe, Anglo-Saxon culture, whatever is related to caramel is successful in general. Really, it's like crazy salted caramel, peanuts and caramel, chocolate and caramel, whatever, actually. In Asia, let's say, they love especially fruits, especially when it comes, let's say, the South East Asia, no, like Malaysia, Indonesia, coconut definitely, no, durian, it's very good. I mean, I don't know if you've ever heard about that, but durian is really, really good seller. And in general, by the way, coffee gelato is growing quite a lot, pretty much everywhere, yeah? Of course, of course. Of course. Yes, yes, yes. All right. Okay, that's it.
Thank you. Thank you, Stefano. Very, very interesting presentation. Okay, the morning session is finished. We are ready for the light lunch. Thank you to the online customers and for the customer here on the site. Actually, we are preparing a light lunch for you. And we have 40-45 minutes for the break. And then we will start with the labs. And drink, of course.